Hey guys! In this video lesson, we would be learning how to determine reaction rates when we are given problems in the form of equations. Let's take up the first problem. Let's read the question first. The question says, in a reaction between C4H9Cl, that is butyl chloride, and water, the concentration of butyl chloride is given to us as 2.2 times 10 to the power minus 1 moles per liter. This is the concentration at the beginning of the reaction. At 4 seconds, its concentration is 1.0 times 10 to the power minus 1 moles per liter. Calculate the average rate of reaction in terms of butyl chloride over the first 4 seconds. Now we have to find out the average rate of reaction. We know the average rate of reaction is written as change in concentration of that particular compound, and they want us to calculate the average rate of reaction in terms of butyl chloride. So here we would take the concentration of butyl chloride over total time. Now change in concentration means the concentration of butyl chloride that is present finally minus concentration of butyl chloride present initially divided by total time taken. Now the concentration that was present in the beginning is the initial concentration, so this is our initial concentration, and the concentration that is present after 4 seconds, if the time total we take is as 4 seconds because they want us to find it over the interval of 4 seconds, then the concentration is going to be 1.0 times 10 to the power minus 1. So that means we have a final concentration as this. So this is our final. We would put it as 1.0 times 10 to the power minus 1 minus the initial concentration is given to us as 2.2 times 10 to the power minus 1. Over the first 4 seconds means time is from 0 to 4 seconds. So the total time is 4. Because these concentrations are in moles per liter, so we would write down here moles per liter, and this is given to us in seconds, so we would write down seconds here. When we put this all on the calculator, we get 3.0 times 10 to the power minus 2 moles per liter, and since we already have a second there, so we would call it as moles per liter a second. And this is how we find the average rate of reaction given the final and initial concentration of a particular compound. Let's take up the next problem. And let's read the question first. In a reaction A plus 2B giving us 3C plus 4D, the initial concentration of A was 0.0415 moles per liter. So we are given information for A. After 14.7 minutes, the concentration of A was 0.0206 moles per liter. So this we can say is after 14.7 minutes is the final concentration. What is the average rate of consumption in moles per liter second of B? Now we would first write on what is given to us. Here we want to notice one thing, that we are given information for A, but what we are required is to find the rate of reaction for B. In the previous question, we were given information for butyl chloride and we were supposed to find out the average rate of reaction using butyl chloride itself. But here, we are given information for one of the substances, but we are supposed to find out the average rate of reaction for some other substance in the reaction. So in this case, we would first find out what is the relationship between B and A. Then only we can find out the rate of reaction of B using the information for rate of reaction of A. But before that, let's write on given. So the information that we are given is, we are given the initial concentration of A. How can we write this down is, A concentration initial is equal to 0.0415 moles per liter. We are given A final concentration that is equal to 0.0206 moles per liter. And the third thing that we are given is time. So this time is, when they say this is initially present, so that means this is present at 0 minutes because we're given the unit minutes. After 14.7 minutes means the final time is 14.7 minutes. So we can write it as delta T is 14.7 minutes. So these three things are given to us. Required, we already know, is the rate of reaction, and the rate of reaction that we're supposed to find out is for B. So we would use the change in concentration of B over total time for B. And one more thing here we have to keep in mind is that the answer they want us in is moles per liter second. So they do not want the time to be in minutes, they want it to be converted into seconds. We would change this 14.7 minutes to seconds by multiplying it by 60, and that gives us 882 seconds. Now we would use all of this information to find out the rate of consumption of B in moles per liter second. For doing this problem, let's rewrite the equation. We're given A plus 2B, that gives us 3C plus 4D. Now remember, whenever we are given an equation and we have to find out rate of reaction can be found out using any of these four substances. And there is a relationship between all of these four substances in a rate of reaction equation. Let's learn how to write that down. So we have rate of reaction. We write it equal to change in concentration of A over time taken, equal to change in concentration of B over time taken, equal to change in concentration of C over time taken, equal to change in concentration of D over time taken. So remember, whenever we are finding rate of reaction, we can write it with respect to any of the change in concentrations of the substances. Could be A, B, C, or D, and they all are equal to each other only and only if their moles are same. But here we see that A has 1 mole, B has 2 moles, C has 3 moles, and D has 4 moles. So how can we make their moles same? Is that we can divide them with the given balancing moles. So this has nothing there, so we do not have to divide it with anything. We can leave it as is. This one, in order to find out the rate of reaction for 1 mole, we divide it by 2, so we would write it as 1 over 2. Here, we would divide it by 3, so we would write it as 1 over 3. Here, because we have to find out the rate of reaction for 1 mole, given is the 4 moles, so we divide the rate of reaction with 4. In other words, just remember, if you're given the reaction and we have the number of moles in the reaction that balance the reaction more than 1, then we take the reciprocal of the moles. For example, if number 2, we take the reciprocal of 2, which is 1 over 2, and we put it in front of the rate of reaction formula for that particular substance. Now, one last thing to keep in mind here is, we know reactants are consumed in a reaction and products are formed in a reaction. Whenever we are equating all the formulas for different substances, we have to mention that in a formula. And how do we mention that? Is with the sign. Minus sign means these are being consumed. Plus sign means these are being formed or produced. Now we can use these ratios 2 at a time or all together depending upon the problem, in order to find out any unknown using the known. In this particular question, we are given known for A, so we will be able to find out A, rate of reaction, but we are supposed to find out the B rate of reaction as a required thing in the reaction. So once we find out the result for A, we can equate it and then we can solve for B rate of reaction. Let's do it now. We are given A concentration initial, A concentration final, and we are given the time taken for A to reach from this initial concentration to final concentration. Let's find this thing out. We know change in concentration of A over time taken is A final minus A initial over time. That is the total time. We know A final, we can see here is 0.0206. So we write down A final as 0.0206 minus A initial is given to us as 0.0415. So we write down here 0.0415 over the total time taken is given to us in seconds. We already found out is 882 seconds. Now when we put this all on the calculator, we'll be able to see that when we subtract this, the result that we get is going to be equal to negative 0.000, and we have another 0 there, 237. We can rewrite it as scientific notation form, so we can write it down as negative 2.37 times 10 to the power negative 5 moles per liter per second, because this is in second and this is in moles per liter. Now this negative sign just means that the rate of reaction from A is basically rate of consumption of A. So we have got rate of reaction of A to be this. We want to find out the rate of reaction of B. This is what exactly we are looking for, and we know we can find out B from A using this proportion. So to find this out, we would rewrite this together. Negative change in concentration of A over time is equal to negative half change in concentration of B over total time. We know this thing is given to us as 2.37 times 10 to the power negative 5 moles per liter per second is equal to negative half change in concentration of B over time. Now we're looking for this, so we would leave everything here and we would isolate the equation. So change in concentration of B over total time would now be equal to, we can leave the negative sign here as well. We can make this number go on the other side. This is being divided with 2 on this side, so the 2 gets multiplied on the other side. You'd get 2 times 2.37 times 10 to the power negative 5 moles per liter second. And final answer that we get is 4.74 times 10 to the power negative 5 moles per liter second. And why is this negative again? This negative sign means that B is going to be consumed. So when we go back to the question wants us to find out what is the average rate of consumption of B. We have found out the average rate of consumption of B is 4.74 times 10 to the power minus 5 moles per liter second. Why do we know that this is consumption? Because the result is negative. We can take the negative on the other side and put this negative here, or we can leave it like this. That doesn't make a difference. So let's quickly summarize this. We're given initial concentration of A, we're given final concentration of A, we're given the total time that A takes to go from this initial concentration to final concentration is 14.7 minutes. We are required to find the rate of consumption of B in moles per liter second. So we change this minutes to seconds because we need the time in seconds. This is already moles per liter, so we do not have to change the units for this. Then we write the equation and we find out the relationship between one substance of the reaction with the other substances of the reaction, and the equation that relates one substance of the reaction with the other substance of the reaction in the rate of reaction is this equation. We need to find out change in B over total time. To find this out, we do not have any information for this, but we are given information for this. So we first find this out using A final minus A initial concentration over total time. Once we get this value, now we can relate these two substances using this proportion equation. And once we do that, we solve for the required thing by isolating our variable. Let's do the next question and let's read it first. For the reaction shown below, average rate of formation of CO2 gaseous is given to us as 5.50 times 10 to the power negative 4 moles per second. Reaction is given to us as bromine plus methanoic acid. When they react together to give us bromide ion, hydrogen ion, and carbon dioxide. What amount in moles of carbon dioxide is formed in 5 minutes? We are given the amount of moles that are formed per second for carbon dioxide is 5.50 times 10 to the power negative 4. We have to find out how many moles of carbon dioxide are formed in 5 minutes. So for that, because we are given information for carbon dioxide and the required is also for carbon dioxide, we do not have to relate it with any of the substances in the equation. All we have to do is just use math for this. So we know in 1 second, 5.50 times 10 to the power negative 4 moles of carbon dioxide is formed. We want to find out how many moles of carbon dioxide is formed in 5 minutes. So if 1 second is these many moles, 5 minutes will be 5.50 times 10 to the power negative 4 moles per second multiplied by 5 minutes. Because minutes have to be changed to seconds as this is in seconds. So we multiply by 60 seconds per minute. How do we solve this? We can cancel similar units. When we put these numbers in the calculator, 5.50 times 10 to the power negative 4, 5 and 60, we get the result equal to 1.65 times 10 to the power negative 1 moles. We can also write it down as 0.165 moles. So we are done. In 5 minutes, we would be able to form 0.165 moles of carbon dioxide. Next is, how does this compare with the amount of bromine that reacts in the same time? Now they want us to use the equation because we are given the information for carbon dioxide, but the required is something for bromine. And how do we relate this? Using rates. We know that we can find out the ratio. And how do we write down the ratio? We can write down rate of concentration of bromine over time is equal to rate of concentration of carbon dioxide. So we can write it as change in concentration of bromine over time equal to change in concentration of carbon dioxide over time. Now what signs and what numbers go here, that is decided by the balancing moles. For each of these, bromine and carbon dioxide, we do not have any moles, so it's basically equal. So we do not have to divide it by any numbers. The only thing that will go here is a negative sign for bromine and a positive sign for carbon dioxide, because carbon dioxide is being formed in the reaction. They want us to find out what is the rate of reaction of bromine, or how many moles of bromine is formed. Because they're exactly equal, we would just say that the number of bromine moles in 5 minutes is going to be 0.165, and we can write it as per 5 minutes. This is how we do part B. Let's take up one last question for the sake of practice. If you're given the question like this, for the reaction shown below, the instantaneous rate of formation of bromide ion is given to us as 0.12 moles per liter second at time equal to 2 minutes. What are the instantaneous rates of formation of bromide with BrO3 negative ion and the consumption of BrO negative? Now from here, when we look into the equation, bromide is given to us. So we are given this. They want us to find out the instantaneous rate of formation of this and the consumption of this. Now from one of the substances in the reaction, we have to find out the rates of the other two substances. And here we notice that this is instantaneous rate, not average rate. Whether they ask you instantaneous rate or average rate, the formula stays the same. And we're not supposed to divide by any particular time. Like for example, here they say rate of formation at 2 minutes. We do not have to divide this by 2 minutes because it's at that particular time when they have found out the instantaneous rate. We have to find out the instantaneous rate at the same time for the other substances too. So how do we write it down first? We would write down the rate of reaction is equal to, this is your reactant, so we would put negative sign, 1 over 3, we have to divide it by 3. Change in concentration of BrO negative over total time is equal to, this is your product, so we would put plus sign, 1 over no number. We can just leave no number, or we can put it as 1 over 1. Change in concentration of BrO3 negative over total time is equal to plus 1 over 2 change in concentration of Br negative over total time. Now we're given rate of formation of Br negative is this. So we can put this here when we're given the rate of formation. So we are given this whole entire thing. We would put this here as 0.12 moles per liter second. If we are supposed to find out this first, that's our first thing to find out. We would just write this down with this. And this is how we put it as plus change in concentration of BrO3 negative over total time. We're looking for this. It's already isolated. We do not have any number here to take on the other side. So we just divide this by this, and the result that we get is 0.06 moles per liter second. Next, we have to find out the rate of reaction for BrO negative. So now we would relate this and this. We can put these two together. So negative 1 over 3 change in concentration of BrO negative over total time is equal to plus 1 over 2 change in concentration of Br negative over total time. We have to find this out. We would isolate this. So we would put it as change in concentration of BrO negative over total time, and we'll move this over on the other side. So this is being divided by 3. 3 gets multiplied here. Change in concentration of Br negative over total time. We can leave the negative sign here because negative just means that this is going to be consumed. So 3 over 2, this is given to us as 0.12. When we put this on the calculator, we get 0.18 moles per liter per second, and this is how we get the final answer for BrO negative rate of formation.